This is episode 124 of the Rule Your Pool podcast. I'm your host, Eric Knight with Orenda, and I'm doing this one alone. We have a lot going on right now. We are just getting into our training season as the summer season winds down. It is getting beautiful out here. I am getting ready to start closing this fixer-upper pool that I have, if you have been following along. I don't know if you follow us on Facebook, but you can find us easily. Orenda Technologies, we're on there. I try to post videos of what we're doing, and I'm about to close the pool, and I have documented everything I've done to this pool chemically. And I want to address, because we do get some questions, no, I have not yet started to destroy my pool. I thought I was going to, and I still will, but things get in the way, and I've realized that this project that I have in my mind, it takes a lot more planning than I thought. So I want to make sure I'm doing it right. I want to make sure that I'm doing things in sequence so that I don't prevent myself from being able to do something else. Something easy like muriatic acid with food coloring. Yeah, I'm going to do that. Trichlor tab on the surface. Yeah, I'm going to do that too. But destroying equipment intentionally, I want to make sure I'm not doing that ahead of myself, and we have everything planned out. So that's why I haven't done it yet. We do have time. We've got this winter. We've got this spring. I'm going to get to it. I still plan on destroying this pool before renovating it and making it beautiful and documenting this process for everybody. I really want to show why we don't do things wrong. I want to demonstrate what that looks like. And that brings me to this episode 124. We are concluding this 4-part series on chemical conflicts. First things first before getting into this. Thank you so much for the feedback. It has been overwhelming. I mean, this is episode 124. We have yet to receive as much feedback as we have from the last 3 episodes. Maybe this struck a nerve with the pool pros and the homeowners out there, but more people than expected have gone out of their way to contact me, whether it's calling or emailing podcast@orendatech.com, that have told me they are immediately implementing changes in chlorine storage and handling for safety reasons. That is excellent news. Thank you. I'm so glad that the podcast episode got to you. A lot of people just don't know these things, and we do not want any of you to get hurt. So safety first, that is a great thing. So, hey, the effort put into this podcast is actually helping people out. I like that. So thank you for that feedback. Otherwise, we would just assume that all, 185 of you now? No, it's got to be closer to 190. I don't know. By the end of the year, we hope to get to 200 people, I think. Yeah, but whatever. The Help Center, ask.orendatech.com. It continues to grow thanks to you. So thank you for the questions that you submit. Those questions get better and better. And I encourage you to search variations of keywords in the Help Center, because a lot of the questions we get, they are actually answered in the Help Center, but maybe the way you're searching is not exactly showing up in the search. So for instance, one of the questions we get a lot is the flakes in saltwater pools. Well, if you just search the word flake, you will find an answer. But if you type in snowflaking, you will not. We don't call it snowflaking. So little things like that, just try variations of your search queries, and you should find some answers in our Help Center. And if not, regular orendatech.com has a search bar on the front. We might have a blog about it. So most questions that we do get, they're already answered. But then again, we have to be generic. So if you have specific questions, feel free to reach out. Again, that's ask.orendatech.com. And at the top, you just submit a question, and that comes to all of us. It's a very efficient way for us to get back to you. And finally, thank you to those of you who reach out after reading a blog and you notice maybe something's outdated. We have over 150 published articles now. It's very hard to keep current. Some of them were written 6 years ago. We may not know that they haven't been updated for a while, and I try to audit content, but it takes a lot of time. And so we've had several in the last 2 or 3 weeks that have looked at, hey, you have these old app screenshots, and the LSI value is different than what I'm getting on the calculator today. Valid point. Yes, it is, because we updated our formula, and it's a lot more precise now. So thank you for letting me know, and I've gone in there and I've been updating those. So thank you for that. That really helps us out. Not that it's your job to make sure that our content is current, but if you see something, it really helps us out to point it out. Just email podcast@orendatech.com, include a link to the page that you're referring to, and I'm happy to go there and review it and make sure it's up to date. Thank you for that. Anyway, that's enough of the housekeeping for right now. This is the final episode in our 4-part series on chemical conflicts, and in this one, we are talking about specialty chemicals. Let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. I'll be honest with you, I thought this series originally was going to be way more episodes. When I originally drafted it out, I thought this was going to be like 7 or 8. I didn't know how many because there's just so many variations of chemical categories and a lot of them overlap. And I thought, man, we could do an episode on this and we could do an episode on that. I think that would just take up too much time in the year. I think we can get a lot of it done in one episode. And fair warning, I'm going to do my best to be concise here and just touch on the common conflicts. I'm probably going to miss some. That's not my intention. I'm not trying to. But you may never encounter some of these more rare conflicts. So I'm just not going to get stuck in the weeds for your sake. I want to value your time and get to the ones that are most common. When I say specialty chemicals, I'm referring to things that are not mandatory in a pool. You need a primary sanitizer. Chlorine is not a specialty chemical. It's a mandatory chemical. It is a primary chemical. pH balancers like pH adjusters, sodium bicarb acid, those are primary chemicals. Calcium chloride, you need that for balance. That's a primary chemical. Now, you may not use it nearly as much as chlorine, but those things are not specialty chemicals. Specialty chemicals are voluntary ones. These are enhancements. They're supplements, if you will. And there's a wide array of them. In fact, we've talked about several of them in the previous episodes. We've talked about clarifiers. We've talked about polymers. We talked about algicides. We've talked about secondary shocks like potassium monopersulfate. These things could be considered specialty chemicals. And to be honest, that's my opinion on potassium monopersulfate, a non-chlorine shock. I consider that a specialty chemical because it's not mandatory. It's not required. But I guess it's a matter of opinion. Some people may say that's a primary. I don't think so. Chlorine is definitely a primary, but it's immaterial. In this episode, we're talking about things that your water doesn't necessarily need, but benefits from them. And let's start with metals. When we talk about metal removal products, there are some great products on the market for this. Unfortunately, we don't have any of them. We have SC1000, Scale and Metal Control, which is a chelating agent. But a chelating agent does not remove metals. You need some sort of filtering mechanism to grab them and take them out of solution and then either discard that or backwash it out. You could put filter additives into a filter that may help increase your screening ability. If you sequester metals, if you remember, we did an episode on this and we've talked quite a bit where sequestering agents are like metal magnets. They'll pull a whole bunch of metals together and it's a much bigger molecule. Whereas a chelating agent like SC1000 doesn't do that. It actually individually keeps the ions separated, but it binds to each one separately and puts them in solution. So a sequestering agent is much better for removing metals because it's a bigger molecule. You might be able to capture it in a cartridge filter or a DE filter, whereas our product SC1000 is not great at this. However, it does work well with metal removing products that you can put in your strainer basket and your skimmer basket. I'm going to summarize. I don't know the technology. I wish I did, but it's some sort of resin that attracts metals in a pouch. It is fantastic. It works really, really well. And those of you listening probably know what I'm talking about. We recommend it all the time. They're a competitor of ours, but to be honest with you, it's a great product. It works really well, and I care more about our customers getting their problem fixed. And SC1000 is compatible with that product. It will work well with it. But PR10000 will not. It's not a huge deal, and I'll explain why. But PR10000 and any phosphate remover is going to be a rare earth compound. Most of them are lanthanum. Ours is not, but most of them are lanthanum-based. Lanthanum is a rare earth metal. It would interfere with that metal removing resin. If you put PR10000 directly in it, I'm not exactly sure what the reaction would be, but the manufacturer says phosphate removers, lanthanides of any kind, which that's a whole category in the periodic table, and PR10000 is in that category. Lanthanides will interfere with that product. Very simple solution. Use that product to remove your metals, and when you use PR10000, take it out. Take it out for a day. Clean everything up, put it back in. Problem solved. And besides, you're putting PR10,000 around the perimeter of the pool. You're not putting it in the skimmer. You're not putting it into direct recirculation like a lot of the other products. Don't do that with PR. If you did that, yeah, okay, it's going to interfere with that metal remover. So that's one conflict that you can easily avoid. Let's move on to citric acid. This is the other side of metal removal. Let's say you already have a stain. It's iron or it's copper or it's manganese or whatever. Citric acid is pretty good at lifting these things and putting them into suspension. This makes it much easier for a product like SC1000 or any sequestering agent to bind to that metal. Then that metal that is now in suspension or solution can be taken through the circulation system into this metal removing filter, and it works really well. But citric acid, also called ascorbic acid or sometimes just vitamin C, some of these products are also oxalic acid, or maybe it's oxalic acid. I'm not sure how you pronounce that word, but these products work. These stain removing products, they lift stains very effectively. Two problems with them. Number one, they wipe out chlorine. Honestly, that's a price that you're just going to have to pay because the benefits far outweigh the cost. You can always add more chlorine. It's a temporary thing. And quite frankly, SC1000 wipes out chlorine too, so I can't hate. They will wipe out chlorine. And number two, they don't work forever. So you got to be diligent and make sure that you have a sequestering agent already in the water when you use them, or SC1000 already in the water. Because if you just lift them, they may not make it to the metal removal. You're going to want to use it in conjunction. And again, I usually punt when we have a metal question with a customer because we only have SC1000. We don't have that full package, at least not right now. Follow the manufacturer's instructions. There's a sequence to this. Kind of like doing anything like a green pool cleanup or a startup. The order in which you put products in the pool and the way that you do that is very important when it comes to remediating metals. If you put them in wrong order, you could have chemical conflicts. So be careful about that. The next one here on my list is back to SC1000 conflicting with chlorine. We've talked about this in many episodes before. If you haven't heard us before and you don't read our blog, and this is the first time you've ever heard us, first of all, welcome. We're always trying to raise that listener number. SC1000 will zero out your chlorine when you purge it. And a purge is the initial dose of 1 quart per 10,000 gallons. The reason it does that is because it takes time to find what it's looking for. And in that time, when it hasn't yet bound to a metal or a mineral, chlorine attacks it and loses. So it's going to zero out your chlorine in minutes. It's just going to wipe it right out. What it needs is time. And you can accelerate the process of getting a free chlorine level to hold by adding it in conjunction with something like calcium chloride if you're raising your calcium hardness, something like that. If you don't, and you just purge the pool, you may not be able to hold chlorine for 3 or 4 days. It's very common. So what we recommend is breaking up that purge dose over several visits. Just be aware of that. Go into our help center or our procedures.orendatech.com. Learn how to use SC1000 effectively. But that is a common chemical conflict with chlorine, but it's a temporary conflict. It still fits our philosophy because we know that that initial dose will wipe out chlorine. But the other side of that sword is all benefit. Doesn't break down in sunlight, doesn't break down by chlorine, whereas sequestering agents will get oxidized over time. EDTA chelants will get oxidized over time, and they will conflict with chlorine anyway. Ours at least just does it immediately. But once it binds to metals and minerals, it's fine. It is now perfectly in harmony with the chlorine in your water. And one big benefit of SC1000 is the fact that it is not phosphate-based, which brings us to the next topic. Sequestering agents are almost always phosphate-based. Not all, but most. The ones on the market are almost all phosphoric or phosphonic acids. That's not a knock on the product. They work really well. They work quickly. They are good products. But PR10,000 will wipe them out in the blink of an eye. The other thing about these products is they don't show up on a phosphate test kit immediately because they are phosphate compounds. They're not orthophosphates yet. As a reminder, in episode 71 of this podcast, we talked about different types of phosphates. Orthophosphate is the building block of all of these compounds, and that's what the phosphate tests pick up. They pick up the building block. So if you have a chain or a ring of phosphates together, That doesn't always get picked up by the test kit. In fact, it rarely does. And this is a big question we get. Hey, we put PR10,000 in the pool. It clouded up like crazy, but my phosphates only went down like 100 parts per billion. What's going on? Well, chances are you had a lot more phosphates than you actually tested for. If you're using a sequestering agent, your true phosphate level is a lot higher than what you're testing, usually. PR10,000 doesn't care. PR10,000 will find it. It will wipe it out, and it will cloud immediately. So it'll take a sequestering agent out of the equation like that. And the problem with that is now all those metals are free. They can either get oxidized, or if it was calcium, they can get carbonated. And now you have a chemical conflict because now the metals are conflicting with chlorine. Your chlorine level goes down. You might get enough to create a stain, which forces you to use new products in the future. And it's this vicious cycle of things. I'm not knocking sequestering agents for what they do. I think there's a time and a place to use them appropriately, and that would be for metal removal. If you understand they are a temporary thing and you're using them in conjunction with something to remove the metals, that's not a bad idea. Just understand the next time you use a phosphate remover, you're going to be wiping that out. So hopefully you have removed the metals effectively. At least that's the idea. But generally speaking, phosphate-based sequestering agents are going to end up in some form or fashion of being a chemical conflict. This is a very, very, very common issue. Now, in my pool, for instance, I've had complete control over everything that's gone in this pool except for nature. I have a lot of trees. I have this slope in my backyard that when it rains heavily, and this has happened twice this summer, it creates a mudslide and it floods my drain and goes right into the pool, and I have a brown pool because torrential rains bring everything in. And as you can imagine, the phosphate levels are ridiculous in my pool. But I'm not putting sequestering agents in there. So you may not have to use a sequestering agent to get high phosphates. I have high phosphates because my backyard. It just is what it is. And by the way, there's over 1,000 phosphates in my tap water here in Charlotte, North Carolina. And that is because drinking water contains phosphates these days. It protects the infrastructure from the city water treatment plants. Look it up. It's pretty crazy. So it's not the end of the world to use these products. Just understand there is baggage that you're going to have with it. The other thing about phosphate-based sequestering agents is they will get oxidized by chlorine over time. So again, SC1000 is an acute wipeout of chlorine. It happens really, really quickly. But once it binds to metals, it's totally compatible. No conflict. It's really the opposite with a sequestering agent. A sequestering agent doesn't zero out your chlorine immediately. Some might reduce it a little bit, but not like SC1000. It'll actually conflict with chlorine over time. So I think we've covered the metal section. That's kind of the crux of this episode. But now let's make a pivot. Let's look at the other side of specialty chemicals. We talked about algicides in a previous episode, so I'm not going to dwell there. But we do need to talk more about polymers, because polymers are not only in algicides, but they are in clarifiers. Polymers, as Terry so accurately put, are polyacrylamides. They are hydrocarbons. They are robust chains that are organic. And they're very good at attracting things, and that's what they do. Enzymes eat hydrocarbons. They break them down. So you will have a direct conflict between enzymes and anything with the word poly in it. So if it's a polyalgicide or a polyquat algicide or a product like a polymer clarifier, enzymes will go after that. And by the way, so will chlorine. So just be aware, if you're using some of these polys, you're going to have a conflict with both enzymes and chlorine. Enzymes go after anything organic, pretty much. There are other products, they're not as widely used, but I think they're worth mentioning here. Certain tile cleaners. Enzymes will conflict with those. Deck sealants. Now, this may not be a big deal, but if you just had your deck sealed, like your paver stones around the pool, and some of it sprays in the pool, enzymes are going to go nuts on that. But more so than that, the stripping agents to clean those sealants off, if you're getting like a pressure washer company in there, we learned this, I think, 2 or 3 years ago. Pressure washing companies were having a hell of a time just trying to keep these pools from turning green. And it's because the product they were using to strip off the original deck sealant was getting into the pool. And these pools were turning green, like green overnight. And our enzymes fixed it. So I don't know exactly what those chemicals were, but purging with the enzyme actually fixed the problem pretty reliably. So we have to imagine it was something organic. If you actually know what those chemicals are and you can send me an SDS sheet or something, podcast@orendatech.com. I'm always open to learning about it. But if you've ever had your deck cleaned, you might know. How about antifreeze? If you have your pool winterized, a common practice in the Northeast and the Midwest is to blow out the lines and put some antifreeze in there. It's great for preventing freezing in the pipes, but enzymes are going to go nuts in the springtime because a glycol is going to be organic. Another one that conflicts with enzymes is liquid covers. Liquid covers float up to the surface of the pool and they reduce evaporation rates, but they are also organic. Enzymes eat these things. CV600 will eat that liquid cover. They are not compatible. You will get a whole bunch of foaming in there. And at the end of the day, any of these compounds that you put in, yeah, they serve a purpose. They do create benefits here and there, but then you have to deal with them. So those are the conflicts I have in my show notes here. I don't think I'm missing any. I'm probably forgetting some. I'm sorry, I'm somewhat scatterbrained, but these are the common ones that we hear about. And I just want to take a step back and revisit why we did this 4-part series. The whole emphasis of our philosophy and our belief system, the whole reason we do this podcast is because we want to help you take things out of your water. We want to reduce complexity. It's much easier to rule your pool when you control the variables. Why would I want to put a bunch of products in my pool that are going to conflict with one another? I'm paying for one and then I'm paying for the other and they conflict, so I've paid twice and I get no benefit. A perfect example, PR10000 phosphate remover and a phosphate-based sequestering agent. You want to know why Orenda doesn't carry a phosphate-based sequestering agent? This is why. We do not have any interest in selling you a product that's going to conflict with another product in our line. This is why we only have 5 products. Well, 7 if you count the spa products, but in a pool, we only have 5 products. Really 3, enzymes, phosphate remover, and chelating agent. The enzymes are split into multiple products like CV700, CE clarifier, that kind of thing. But the point is they're all compatible with one another. They are designed that way. We don't want any chemical conflicts. That leaves you with less money in your pocket, and your water is now more complex because now you have other byproducts. Great. That is not ruling your pool. That is inviting problems into your pool. Let's take things out. I don't want to put organic products in my pool. Sounds good from a food standpoint, but we're not talking about food. I'm talking about hydrocarbons. I'm talking about oils and non-living organics and contamination. I don't want to put in products that are going to increase the oxidant demand on my chlorine. That's what's going to happen. And that's why we use enzymes. We want to get those things out so that we don't use up chlorine, because chlorine has a very, very, very important job in pools. And it's not getting rid of oils. It's killing germs. It's killing algae. Yet, over 90% of chlorine's job is the oxidant demand. It's not very good at oxidizing compared to its strength as a sanitizer. So let's free it up. Let's get chlorine a chance to do what it does best, and let's get these other variables out of the water. Let's avoid chemical conflicts, and let's not put in products that leave long-term byproducts behind. This is episode 124. This is the final episode of our 4-part series on chemical conflicts. I'm Eric Knight with Orenda. I am so grateful for your feedback. Thank you for all of you who still listen. I hope you found value in this and the previous 3 episodes. If you have questions, podcast@orendatech.com. If you are trying to implement the Orenda program, reach out, search our site, type in the word program. You'll find it. It's a pretty simple process. It looks like a lot when you first read it, but it's actually pretty intuitive once you get into it, and we are here to help you. Thank you so much. Tell your friends. We love you.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.
Silly me. Where are my manners? We opened this 4-part series with this song, and now we're going to close with it. Back by popular demand. Take care, everyone.
Keep your chemicals separated. Podcast is gaining traction like we cannot believe. Old school pool guys in and out of the backyard, slugging acid shock with chlorine and leave. These old bad habits gonna catch up somehow. Mix the wrong two things together and it's all over, pal. Add your products to your pool that really shouldn't mix. They're gonna trash it up, trash it up, trash it up, trash it up. Hey, you got conflicting chemistry? Take it out, keep chemicals separated. Hey, got 3 different chlorines? Take one out, keep your chlorine separated. Hey, keep this in mind. Measure your acid and dilute it in a bucket every time. Hey, rule your pool this way. By the time you see algae, it's already too late. Can't hold chlorine for a week in the summer. Check your oxidant demand and then your cyanurate. These pools are all the same as the thousands before. Instead of testing water first, no, I'll just shock it some more. Your never-ending spree of always chasing pH is gonna make you lose hope, make you lose hope, make you lose. Hey, you got conflicting chemistry? Take it out, keep chemicals separated. Hey, you got 3 different chlorines? Take one out and keep your chlorine separated. Hey, keep this in mind. Measure your acid and dilute it in a bucket every time. Hey, rule your pool this way. These old bad habits gonna catch up somehow. Mix the wrong two things together and it's all over, pal. Add your products to your pool that really shouldn't mix. They're gonna trash it up, trash it up, trash it up, trash it up. Hey, you got conflicting chemistry? Take it out, keep chemicals separated. Hey, got 3 different chlorines? Take one out, keep your chlorine separated. Hey, keep this in mind. Measure your acid and dilute it in a bucket every time. Hey, rule your pool this way.